All right, so the first topic that you'll be covering, and if you looked at our transition notes here, our timeline, is on rounding, significant figures, data variables, tables, and charts. Basically, univariate data and bivariate data. Okay, that's what we're going to be focusing on for this during the commencement. We may or may not get through all of it, depending on how quick we go through the content. That also means we may or may not get through that CFAT, and that's okay. All right, we can push that to next term if we have to. Okay, but just so you understand, this is what we're going through. Okay, rounding, significant figures, data variables, tables, and charts. First thing we're going to focus on today, and we may not even get to doing the work, is on rounding and significant figures. So this first part here. Okay. So, right, let's get into this. Right, so approximations, decimal places, and significant figures. I'm going to give you this short overview of what we're going to do in this lesson. The idea behind all of these words, approximating, a decimal place, and a significant figure, is you're trying to decrease the amount of numbers that you're looking at, or make a number smaller so it's easier to work with. Okay? Looking at the values of the digit to the right of a specific. So when you're rounding a rule, okay, or you're rounding a number, if you've forgotten how to round, the idea is you're looking to the right of a specified digit. Okay, let's say for example you have 38.57. Okay, and I want you to round it to one decimal. Okay, that means you're looking at one number after that decimal point. So that means I just want one number after that decimal point, which means that this is the only number, okay, that I want to see. Now, looking at that number, it is a 5, and according to this rule, okay, you have to look at the number beside it, which is a 7. If you don't know how rounding works, if the number that you're looking at, which is this, okay, and if this number here, okay, is 5 or higher, and then it will affect this number. So instead of 5, okay, this 7 is going to change this to a 6. Okay, if it was 5, 4, for example, this 4 is too low to affect the 5, so it'll just stay as 5. Okay, and that's what he's talking about here. Okay, and I think sometimes the explanation part doesn't make as much sense as the practical you doing it part. Okay, so let's look at this example here. We're going to round 34,867 to the nearest 1,000. So looking back at what you learned in year 7, 8, 9, 10, thousands. Okay, you're looking at your thousands values, okay, or your place value of the thousands. So what that means is this is your tens of thousands, these are your thousands, there's your hundreds, there's your tens, and there's your ones. Thousands means I want to affect this, or effectively change this value here. Okay, rounding it to this thousandth value. So look for the first digit after in the thousands. Okay, in this case, after the thousand, sorry, in this case it's an 8. That means this 8 is going to affect what happens to that 4. Okay, and you can see in this example here that 8 changes the 4 to a 5, so you get 35,000. Notice as well that the rest of the values now become 0. Okay, because the main thing I want to focus on is in the thousands section, which is this. Okay, so rounding, basically, it's just trying to give you a short, or trying to represent the numbers easier, so it's easier to look at. Okay. Alright, so that's for rounding. Again, pretty basic. I assume most of you guys still remember how to round your numbers. Alright, let's go to the next part on standard form or your scientific notation. So this is where what I mentioned before, it becomes a bit more obvious. Okay, when you're working with a very, very large number or very large small numbers, meaning you've got heaps of decimals or just a bunch of numbers after the first number, what we like to do is use what we call scientific notation. Okay, it's basically just trying to represent that value in an easier way. Okay, because it's too much. We want to make it easier to work with. Okay, so there's two names for it: scientific notation or standard form. So you might see it in your SAC on your exam saying, "Oh, I want you to put this number in standard form." It's the same as scientific notation. All right. To write a number in scientific notation, we express it as a number between 1 and 10, so keep that in mind. Okay, you're expressing the number to be something between 1 and 10. Okay, so that means the number can't be like 21 and then something else. Okay, it has to be between 1 and 10. It can be like 1.3 or 1.45. or it could be 9.2. Basically, any number between 1 and 10. And then after that, you're multiplying it by 10 to the power of 10. Sorry. So it's 10 to the power of something. Again, it'll make more sense when we put it in these examples. So let's say, for example, you've got 2, 4, 9, and then a bunch of zeros after that. And you want to present this in scientific notation. Okay? So again, this is too big. It's like, what are you going to do with this? Okay, it's too much. So what you want to do is represent it in a smaller value. And what you're looking at here, what you can see, the pattern that you can look at is, look at the number, okay, and look where the decimal is at the moment. I can see that the decimal must be here somewhere at the very end, okay? And what's happened here is they've moved the decimal place, okay, back all the way over here. So that, remember, the number that you're representing has to be between 1 and 10. So instead of 249 and then a bunch of zeros, it's going to be 2.49. Okay, and then so where did that get this 10 times 10 to the power of 11? Well, that's basically the number of times they've moved the decimal place. So if you look here, I'm going to zoom right in. If the decimal place was over here, and you're changing this number to 2.49, so the new decimal spot is right there, you're basically moving the decimal point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 spots. Okay, that's how we get that power of 11. Okay, so again, the idea is you want to represent this number between 1 and 10. So in this case, it's 2.49. You can't do 24.9 or 0.249. It has to be between 1 and 10. Okay, so it's going to be 2.49. And if that's the case, count the number of times that decimal point has moved. In this case, it's 11 times. Okay, with a smaller number like this, decimal number, so the decimal point is here, and you've got 0.00000, whatever many zeros, 2. So you want to put that decimal point over here. Okay, so in this case, that decimal point is there. How many times have you moved it? Well, you got 1, 2, 3, 4, 5, 6, 7, 8, 9. So because this is a decimal, just make a note that it's going to be to the power of -9. If it's a little small decimal number of this, like this, power of -9. If it's a big number, it's a positive number. Okay. Again, you do a bit more practice to this so that it makes more sense. So basically, all that I just mentioned is there again, so you can read through it if you need to. But let's do some for example. Okay, so I want to change this to scientific notation. Let's do this one now, this number here. Remember, the number has to be between 1 and 10. So that means it can't be 78 or it can't be 0.78. It has to be between 1 and 10. So anyone want to tell me what would this number change to first? 7.8. Okay, so it's going to be 7.8 times 10 to the power of something. Now, if it's 7.8, your decimal point was initially here, but now it has moved over here. So how many points has it moved? So it's moved 1, 2, 3, 4, 5, 6. So it's going to be 7.8 times 10 to the power of 6. Okay. And if you wanted to test it, you can actually put that on your calculator. I don't know if it'll work on this, but 7.8, okay, times 10 to the power of 6 should give us, the same number. Okay. All right, next one. Boys, what have I said already? Okay, you're going to be heard in this recording now. YouTube is going to hear you, me telling you off. Okay, please be quiet. All right, this number here, remember, that number has to be between 1 and 10. So if you want to represent this, what should you change this number to? Firstly, 5, right? So it's going to be 5 times 10 to the power of something. Okay, notice then, because this is a really small decimal, it's going to be to the power of a negative number. But what is it? So if I move my decimal point here, let's count it. 1, 2, 3, 4, 5, 6, 7. So it's 10 to the power of -7. So that's the scientific form or standard notation of this number. 5 times 10 to the power of negative 7. And if I do that on my calculator, okay, 5 times 10 to the power of negative 7 should be 0. However many zeros there are, 0.5. Okay, does that make sense? Yes, no, maybe we'll do one more example. Let's go, just do one here. Let's go like 3, 5, 2, 0, 0, 1. 0, 0, 0. Let's leave it at that. Okay. This number, remember, I want to represent it scientific notation. What should it become? Okay, 3.52. Okay, so now the decimal point is here. It used to be here. Okay, but how many times did I move it? So it's going to be 1, 2, 3, 4, 5. So I've moved it 5 spots. So times 10 to the power of 5. Okay, let's try another example. What if it was 0.00123? Okay, let's try that number. I want to represent this, okay, in scientific notation. Remember, it has to be between 1 and 0. So you can't have 12.3 or 0.0123. It should be 1.23. Okay, times, okay, 10 to the power of, well, if it's 1.23, the decimal point has now moved here. Okay, how many times did I move it? Well, I've moved it 1, 2, 3. So to the power of negative 3. Okay, I'm hoping that's making sense so far. Alright, this one here is pretty straightforward. Okay, I've kind of been doing it on my calculator before. Okay, but what we're doing here is now writing scientific notation number as its basic numeral. So what's its actual value, the complicated value? Okay, so for this, I'm going to open my CAS so you can see how this works. Okay, this is a CAS calculator. You'll be looking at this a lot. If you want to get a calculator open, it's this one here. Okay, add a calculator. I highly suggest you use that instead of calculate. Okay, so there's my calculator. Nice and easy. We're going to go to solve this, to write it in basic numerals. You're basically just typing this in your calculator. So 3.576 times 10 to the power of 7. So my calculator, 576. So 576 times 10 to the, this is your power button here, just so you're aware, to the power of 7. All right, 7 equals, well, if that happens, you can press Control Enter. No, it won't. Okay. So what this is saying is basically it's a decimal point. You're moving it 7 times. Okay, that's what that is. The calculator might not always represent it because of the setting, so I might need to change my settings. But what's happening here is basically you're moving that decimal point 7 times. That's what that's saying. So from there, if you moved it 7 times, let me write it here actually. 3.576. I'm moving this decimal point 7 times, so it's going to be 1, 2, 3, 4, 5, 6, 7. And in between all of those, where the decimal points have moved, there should be zeros there. So the actual value for this should be 3576 with 4 zeros after it. Okay, because it's 3.576 times 10 to the power of 7. So that 7 tells you that the decimal point gets moved 7 times. Now that's 7 times that way. Okay, so in the positive direction. Which way do you guys think this will move? The left. Okay, so it's going to be a really small number in negative direction. So if that's going to be that 7.9, okay, I'm going to move a decimal point 5 times to the left. That's going to be 1, 2, 3, 4, 5. Okay, so the decimal point is right here. So you've got 0, 0, 0, 0. Don't forget to put a 0 in front of that decimal point. Okay, so you know that it's a decimal number. So that means it's going to be 0.00079. One more 0, 7, 9. Okay, so that's its basic numerical value. All right, let's see. Just give me a sec. I might skip ahead. Okay, decimal, rounding. Okay, I might stop there. Okay, and stop explaining, and we might skip a little bit of these notes, and I want you to start on the exercises. Okay, there's not that a lot.